Hey girls, I hope you're enjoying your holidays and welcome to my makeshift classroom in the kitchen of Palmerston. I hope you can see everything really clearly. I've got notes up here on the computer screen, and then down here we've got my makeshift whiteboard, and my video camera is hopefully not going to fall off this tripod. Alright, I apologise if anything isn't totally clear. If not, I'll have to reload it later. Anyway, alright, enough of the rambling. Okay, so today we are going over 1C and normal distribution. So in the past we have learned about the mean. So just to refresh our memory, hang on, can you see that? Yep, so down here. So just to refresh our memory, X bar is the mean, and we're going to use SD as our standard deviation. Alright, I really hope you can see that clearly. Alright, so we know that our mean is the middle, or not the middle, but the average of a set of data points. And the standard deviation explains the spread around the data. So what we can do is, with our mean and our standard deviation, what often happens when we graph our data is we get something that's called a normal distribution. And a normal distribution, when we graph it, looks a little bit like this. Pretend that's really, really even and not wonky and not off center. So this is called the normal distribution, and it is often also called a bell curve because it sort of looks like a bell. You can imagine that's a little bit that hangs down and goes ding, 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 ding. All right, so this is what we get from a lot of data. So when we get data like this, it's called the normal distribution. And when we have a normal distribution, there are certain qualities to this graph that we can use to predict things. And to find out information with probability and percentages. So when we've got a normal distribution, our mean is always exactly smack bang in the middle. All right, so our mean will always be in the middle of our bell curve. Now our standard deviation will determine what our graph will look like. So if we have a small standard deviation, what that means is that we have a small spread of data around the mean. So that means that our graph is going to be really tall and skinny because there's not much spread. The standard deviation is only small. If we have a large, I'm really bad at drawing, I'm out of practice. If we have a large standard deviation, that means that we have a greater spread around our mean, and so our bell or our normal distribution will be more spread out. Alright, so even though when we're doing these questions, most of the time our bell curves will look exactly the same, we just need to know that, yeah, we're just doing that as a representation, so we've got something to look at when we're drawing. But a small standard deviation will be a tall, narrow graph, and a large standard deviation will be a spread out, shorter graph. All right, so now we're going to have a look at what we can do with this. Oops. Okay, one thing you do need to know is back up at the computer. Okay, right here, this is the function for the curve. So if we were looking at drawing that exactly, this is how we get our function. We don't need to worry about that now, but it's just so that you know what that is. Alrighty, let's get darn excited. This is my favourite ever rule of all time. This is like just, oh my gosh, it's so exciting. It's just the best. I'm pumped. Alright, cool. This is really, really cool. Alright, so we have the 68, 95, 99.7% rule. So this is my favourite statistics rule ever. Yes, I am still really excited. All right, yeah, and I've quoted that, so don't go stealing it. Okay, so what we can see is I'm going to draw it on our whiteboard down here as well, but keep following along with your notes because that's exactly what I'm following as well. So I'm just going to push this down. Okay, so what we've got with our bell curve. Okay, so we know that the mean lies, pretend all my bell curves are exactly even. Alright, we know that the mean lies smack bang in the middle. So that means that 50% of our data lies below the mean and 50% of our data lies, that's it, you got it, above the mean. All right, no matter what you bell, whether it's tall, wide, whatever, 50% of the data is below the mean, 50% of the data is above the mean. All right, that's where we're starting. So this is where it starts to get really, really cool. So if we have got this bell curve, okay, I'm going to start to draw it a little bit. I'm going to draw a big one because I'm going to start drawing all over the shop. So let's get a really big one. Ooh. All right, we all know I'm a fantastic drawer. Okay, so we still have our mean in the middle. So we've got 50% on this side, 50% on that side. Now, if we were to go one standard deviation below the mean, so this is one standard deviation below and one standard deviation above, all right, in this section, so between one standard deviation below and one standard deviation above, 68% of our data lies in here. So 68% is in between these two. All right, so we have between below one standard deviation and the mean, we have 34% of our data, and between our mean and one standard deviation above, we have 34% of our data. 34 plus 34 equals 68. That is where 68% of our data lies. So if that's where 68% of our data lies, we should know that there is, well, let's go 100 take away 68, because we know there's 100% in here. What's 100 take away 68? Come on, brain. It's the holidays. I just can't be bothered using it. All right, equals 32. So we know that 32% isn't in this middle part. But we know that it's split evenly on both sides. So 32 divided by 2 equals 16. So we know that there's 16% of data in here, and we know that there's 16% of data in here. So that's our 68% rule. That's to do with one standard deviation. One standard deviation below, one standard deviation above the mean. All right. Now, something else that is extremely cool, like yo cool. At one standard deviation below the mean, so we're at this point exactly here, this is an inflection point. Now, my diagram is not exactly accurate, my inflection point's down here, but it should be an inflection point, and so should this. Okay, now this isn't going to be, we're not going to be using this straight away, but you need to keep this in the back of your mind that these are inflection points. One standard deviation below is the point of one inflection point, one standard deviation above is another inflection point. Don't get too much bogged down in that though. All right, so hopefully you've got that in your brain. So that's the 68% rule. Now we're going on to the 95% rule. Alright, and that's pretty similar, but this time, instead of using 1 standard deviation above and below the mean, we're going to use 2. So, our mean is obviously still in the same spot. X bar. Alright. Our first standard deviations are still in the same spot. Alright, now we're going out to our second standard deviation. So, in between 2 standard deviations below and 2 standard deviations above, we have 95% of our data. Right, so 95% of our data lies between 2 standard deviations below the mean and 2 standard deviations above the mean. Now I'm just going to stop here, otherwise I won't be able to load this to YouTube.